Okay, to test an ozone cell with our new test box, first you're going to disconnect the cell from the generator. You can leave it in the generator, but you need to disconnect the high voltage lead from the transformer and any other cell, so it's completely isolated. The ground can remain hooked up, so you can leave the cell in the chassis. You're going to put the generator in purge mode so that the ozone cells are at normal operating pressure and flow. Flow is not as important, but generally you just put it in purge mode so it's going to be at pressure and flow. From our test box, you're going to open it up. You're going to connect the high voltage lead from, first make sure it's unplugged and the toggle switch is turned to the off position. Take the high voltage lead, route it as away from any chassis metal as you can. It's not necessarily going to fault if it's by metal, but it's best if it's insulated from any grounded metal. Hook that up to the high voltage lead with the alligator clip. Take the ground wire from the test box, hook that up to the chassis ground so that it's grounded to the cell. This can be on a grounding bar or directly to the cell itself. Then you're going to plug in the test box to a 115 volt outlet. Again, make sure the toggle switch is off when you start this. You do have 230 volts because we have a step-up transformer in here to feed the power supply. So on the power meter, you're going to have the voltage and wattage, frequency, current, and all that information. When you're ready to test it, you can turn it on from the cell. Now you can have cooling water or not. It doesn't matter. The tests are generally pretty short, so the cooling water is not as that important. But you do need to have it at pressure, and preferably with dry air source or oxygen, whatever your normal feed gas is. If there's high dew point air going through the cell, it could cause it to fail, even if it's not a bad cell. So the potentiometer on the power supply does adjust the output power. So turn that to counterclockwise to have it all the way down. Keep clear of any of the high voltage leads so that you don't get yourself shocked. And you're going to turn on the tester. You should see the frequency start modulating. It comes down as power goes up. Minimums roughly 15-20 watts. You'll see as you turn up the potentiometer, you'll see the frequency begin to drop. Wattage should go up. You're watching for the wattage to continue to go up. On a good cell, it'll go up to about 400 watts. On a bad cell, that wattage will not go up, and the frequency will not go linearly down as you go up in power. You're also listening for any chattering or arcing in the cells. As I'm turning up power, this cell is arcing. The power meter is kind of freaking out, and the frequency is not doing what it should. So it's clearly a bad cell. You won't always hear a arcing like that, but if the cell is bad, the frequency will not follow the normal routine of dropping down to roughly 7,000 to 8,000 hertz as power goes up, and you won't get the wattage that you expected. Now, you don't normally see the display reset like it did on that last test, but occasionally with the arcing you get some abnormal transients and arcing. I'll try it again. You hear that one, and the screen just reset again. That's just the inductive interference causing that screen to reset. Yeah, the frequency is all over the place. It definitely doesn't like that cell, and that's how you would tell the difference. So turn the potentiometer counterclockwise, turn it back down, turn it off. If you see an abnormal error like OC3 or something of that nature, you can reset it just by pressing this reset button. That'll clear that. You shouldn't see that. We've eliminated that. We're turning the sensitivity way down on that because it doesn't really function for what we're testing here, but a normal cell that works, you'll just generally hear a high-pitched hissing sound, kind of like static, as it goes up in frequency and power, and you will See the frequency stable at around 7,000 to 8,000 hertz and the wattage up around 350 to 400 watts. We'll check a good cell next. I'll show you how that reacts. All right, I've swapped the cell out to a different cell. Now we'll try to repeat that same test. Now I've got the potentiometer at minimum. I'm going to activate the power switch. Same thing, we've got frequency around 9,000 hertz, about 15 watts. Okay, I'm going to gradually turn up the potentiometer. You can hear the hissing sound. I don't know if you can hear that from the cell. Sounds normal. Turn it up. Alright, I'm up to full power. I'm at 7,600 hertz. 420 watts. Now this cell might need to be purged a little bit longer, but that's a normal cell. You get stable frequency and a stable wattage up around 400 watts. It should not jump around and oscillate the frequency like that other cell did, and you don't hear the arcing. And as before, when you're done with the test, turn the potentiometer counterclockwise to turn all the way down, and then switch off the power switch to shut off the high voltage. Now the test box is not designed to run at higher outputs for more than a couple of minutes at a time. It's just for testing cells. It doesn't really have adequate cooling in the box to cool it if it was running at higher levels for a while. Plus the control transformer we're using to step up the voltage from 115 to 230 isn't really powerful enough to run it at outputs more than 200, 250 watts for very long. But for test purposes, you can get your 400, 450 watts or more out of it for brief periods if you just need to test a cell. So that's how you use our new test box.